So today what we're going to do is we're going to begin our look at algebra. Now I know that you've been introduced to algebra in your year 7, most of you, okay? But we're going to go through some of the basic ideas and basic facts and look at some examples of how you can use algebra. What does algebra mean? Why is it different? And what you need to know about it, okay? And the first thing is, don't be afraid of algebra. The only difference between arithmetic, now arithmetic just means operations, and remember there are only 4 operations: add, subtract, multiply, and divide, yeah? It's just operations with numbers. Okay. With algebra, it's still operations with numbers, but it's operations with numbers and unknowns. And that is the main difference. But what it allows you to do is, it allows you to do a lot more math, even though you don't know all the pieces that you need, okay? Now, it's still the same 4 operations. You're never going to do anything other than add, subtract, multiply, divide. If you can find me a time when you do anything other than those 4 operations, then I will give you 8s on everything else and you can sleep for the rest of the year, because it doesn't exist. Now, that should be good news to you, because there's only those operations. And remember that your calculator can do most of those, right? But the issue with mathematics, and in algebra particularly, is that you need to know when to do which operation. Okay, so keep that in mind. You're only ever going to do those 4 things, but you need to know when. Just like knowing the difference between area and perimeter, right? So keep that in mind. So you need to study your notes and make sure that you really have a good understanding of what your notes are saying and the process, the methods, yeah? Now, we call those unknowns variables. And the reason we call them variables is because their value can vary, right? So you could have x be 5 in one question, and it might be -3 in another question. So their values vary, so therefore we call them variables. And what we do is we represent those unknowns with letters. Now, many, many times, as you're going to see today, we try to use letters that make sense to the problem that we're trying to solve. For example, if you're trying to find out how many dogs, then use D for your unknown or your variable. Right? If you're measuring carrots, then use C. Whatever you're measuring, you try to use the first letter or some letter that represents that idea. But later, as we move forward, you're going to see that most of the time, we just simply use the letter X. And the reason for the letter X is because not many words start with X, so we just use the value X, meaning any unknown. We don't know what value we're looking for. We're looking for some unknown number, so we just call it X. So don't be afraid of those unknowns, those variables. They just stand for some number that you don't know the value of yet. But that doesn't mean you can't find the value. So we'll be finding those values. Okay? So what is the only difference between arithmetic and algebra? Sing out, guys. Can you hear me?
Algebra has variables.
Variables. There you go. Use the right word. Yeah, so the unknowns, which are called variables. There you go. Now, you got to still participate with me because you know I get lonely. Okay, so especially just sitting here by myself talking to myself. It feels like I'm talking to myself. It's really weird. Okay, sometimes it feels like that in class, though, so it's okay. Now, not with you guys. So what we're going to do is we're going to look at a few examples of this and how to write some algebraic expressions and algebras, which are just algebraic sentences. We might as well go ahead and put that down. So we're going to be working today with creating and looking at some algebraic expressions. And those are just algebraic sentences. Now, I keep using that phrase algebraic, and you know that it's algebraic because you have the variable, the unknowns, the letters, okay? We like to call them variables, but if you call them unknowns or letters, that's fine, but try to get used to using the right word. So these are algebraic sentences. So in other words, you won't have 3 plus 5 equals 8. You'll have 3 plus x equals 8, right? Where we have an unknown, one of our numbers is unknown, okay? And that's what makes something an algebraic expression, okay? We're also going to talk about, actually, the thing I just gave you was an algebraic equation because it had an equal symbol in it, but we'll talk about those later. So algebraic expressions just means you're writing a sentence using the variables to represent your situation, okay? And again, we're going to go through several examples so you can see exactly what I mean by that. So let's go to our Snowflake and look at some of these. So I'm on page 139, so you know where we're going to be in this section. So look at this first opening problem. Let's just move to the writing algebraic expressions. So the symbols used in writing algebraic expressions are called variables or unknowns. We prefer the word variable because that's what you're going to hear from now on. So don't get used to a word that you're not going to be using later. So for example, there are D dogs in a kennel. So I don't know how many there are, so I just call the number D. Okay? So the variable D represents the unknown number of dogs. So it's not, algebra is very simple and very straightforward. It's very logical if you think about it, right? If 2 more dogs are added to the kennel, there are now D plus 2 dogs. So we still have our unknown number of dogs, but now we can use a number because we know how many more dogs were added. Yeah? So we know that number is 2. Now, don't put 2D because this is just we know exactly what the number is. We still don't know how many dogs there were originally, but we know we've added 2 to it. Okay? And this is called an algebraic expression, and it says involving D, but we usually call it in terms of D. Okay? But algebraic expression involving D. So let's look at an example here. Brent, Scott, and Takesha are sharing a bag of peanuts. Suppose Brent eats B peanuts. So they didn't say use P for peanuts this time, but you could. That unless they tell you specifically what letter to use, you can choose whatever letter you want, guys. Scott eats 1 less peanut than Brent, and Takesha eats 3 times as many peanuts as Brent. So B stands for the number of peanuts that Brent ate. Yeah? Because it says Brent eats B peanuts. So pay attention if one of them, if they're going to be using the same thing over and over again, one of them is usually just plain old B. That it says Scott eats 1 less peanut than Brent. So if you look, Scott eats B minus 1 peanuts. So we know that he ate 1 less, so 1 less means subtract. Takesha eats 3 times as many times, so multiplication, so just 3 times B peanuts. And we're going to talk about ways to write this and some key phrases and words that will represent the different operations as well. Okay? So, pretty straightforward, yes? So we're going to do a couple of examples, and this is your exercise, 7A.1 today. Suppose a bus has P passengers. 7 passengers got off at the next stop. How many passengers are now on the bus in terms of P? Well, I originally had P passengers, but 7 got off, so is that adding or subtracting? Subtracting, good.
Subtracting.
So I'm going to take 7 away, so I now have P minus 7 passengers. So difficult, yes? Okay. All right, let's scroll down a little bit. Look at number 3. A man is N years old. Okay, so this is his current age. So how old was he 12 years ago? Well, we don't know how old he is now, so we're just going to express that with N years. Now, again, they could have used Y. It doesn't really matter if you want to use letters that you know. But in this case, be careful, because when you're answering these, they're giving you specific letters to use. So use their letters, please. How old was he 12 years ago? Well, 12 years was in the past. So we're going to be adding or subtracting? Subtracting. Good. So subtract 12. So you get n minus 12 as your algebraic expression. Right? The man's wife is 6 years older than he is. How old is she? So his age, and she's 6 years older. Is that addition or subtraction?
Addition.
Addition. And so she's 6 years older, so just add 6. The man's mother is twice his age. How old is she? So again, his age is n. Twice is a special mathematic word. What does twice always mean? What operation?
Times.
Times, good. Multiplication. But twice is a specific number. Multiplication by what number?
2.
Yes, there you go. So 2 times n. Now notice that when you're doing the addition or subtraction, you would put that after the n, but when you're doing multiplication, you put that in front of the n. Right? So make sure that you're looking at the order, because we couldn't say 12 minus n, because that means you're subtracting his age from 12. So you've got to pay attention to the order in which they're written. Okay? Now, you could, at this stage, do n times 2, because those two things mean exactly the same thing. Because remember that multiplication and addition can be done in any order. But get used to putting the number first in multiplication, second in addition or subtraction. How's it looking? Pretty easy? Not a bad way. Not a bad way to start online learning. All right.
No.
Let's do the next one. My neighbor has X cats. Now again, you could have used C for cats, but in this case they want you to use your X, so please conform to the letters that they want you to use. So he has X, oops, sorry, forgot to push my button. X cats. All right? If write an expression for the total number of tails. Okay? Well, how many tails does each cat have? Assuming they all have one.
1.
One tail. So 1 times X, and of course, you guys to represent it, because you can just use that funny little curved X, right? You've seen that before. In the States, I would do this, because that dot is the multiplication symbol. So you can do it any way you want to, but traditionally here, y'all use that, so I'll try to conform. You know, it's hard for me sometimes. All right. So 1 times X, but if you multiply anything times X, does that really, or if you multiply anything by 1, does that change the number?
No.
No. So you could just say X tails instead of 1 times X, because 1 times X is just X, right? Because anytime you multiply times 1, you get the same thing you started with. All right, let's do eyes. Okay. So, how many eyes does each cat have?
2.
2 times our X. Okay, oops, sorry, we're not simplifying these yet. So 2 times X would be our expression for that. And finally, legs. They each have 4 legs, so that's just 4 times the number of cats would equal how many legs? Okay? All right, let's see what else they do to you. So pretty straightforward writing those expressions. Here we have, so we're going to look at a few expressions where you have more than one operation. In the fridge, there are 2 punnets with strawberries in them, plus 4 strawberries left over. So you see they've drawn a little picture there. Write an expression for the total number of strawberries if there are 6 strawberries in each punnet. So 6 per punnet means that there are 6 in this one, right? And there are 6 in this one, plus these extra 4. Okay? So there's no unknown we know. So in other words, they're not giving you an unknown anymore. They're telling you how many are in each one. So this is just going to be a straight arithmetic sentence. There are 2 punnets. Each one has 6, so that's 2 times 6, the number of strawberries. and plus the 4 extras. All right? So there was no unknown in this particular case because they told you how many strawberries there were. So in the original one, though, we had 2 times, oops, let's not use x, I don't like writing, the number of, we'll use punnets. Punnets plus 4 more. Or you could do 2 times strawberries plus 4. But since they told you how many were in each punnet, we were able to actually put a number in place of there instead of an unknown. But the original situation, this would have been our algebraic expression. Okay. 9 strawberries have been put in each punnet, so that's just 2 times, instead of 6, we have 9. S strawberries have been put in each punnet, so 2 times S plus 4, so there's that algebraic expression. So you see that S can be any number in this expression, and it would make this sentence true. Okay? So if I had 5 in there, it would do 2 times 5 plus the 4, etc. So let's look and see what we got here. A farm has 6 paddocks of horses plus 5 stables with 1 horse in each. Write an expression for the number of horses on the farm if each paddock contains 2 horses. So how many paddocks do they have?
6.
6. So 6 paddocks. Okay. And the first one, they told us how many horses are in each paddock. So that's just 6 times 2. But then there's plus 5 more stables that have 1 horse in each. So plus 5 more horses. Make sense?
Yes.
Okay.
Yep.
Let's look at the next one. Now we're going to increase the number of horses in each paddock. We still have 6 paddocks. We still have the 5 horses in the stalls. But now we have 4 horses in each paddock. Okay. And then finally, they want us to just do it as a general algebraic expression. So 6 paddocks times H horses plus 5 more. Okay. Now, even though those are horses, don't put an H on that one because that's a known value. We only put the H in for the unknown values. Okay. We know how many horses there are in the stables. We just don't know how many there are in the paddock. Okay. All right. Let's see. I think that is... they're going to go a little further. No, we're going to do that next time. We're going to talk about some more about the algebraic expressions. I just want you to get your feet wet and get your mind around working with unknowns. And then next time we're going to go forward a little bit. Now, I do this a little differently than they do, so hold on and don't go too much forward. You'll have other work to do in your other classes anyway, so try to just stick with this lesson, and then we will continue as we go. So what I want you to do, obviously we've done the odd numbered exercises, so you don't have to redo those, but if you'd like to, that's fine. So, but I want you to do exercise 7A.1 on your Snowflake, and you can just do the even numbered ones because we did the odd ones, but if you want to go back and redo those even ones just so that you have a little more practice with it, that's perfectly fine. Okay, come bring you guys back. There we are. Okay, so looks good. Can't get this adjusted.
Bye, Mr. South.
Okay, all right. Well, hold on a minute. Don't get say goodbye so quick, brats. Are you really that anxious to get rid of me? Oh, I see how I really... So sad. Okay, no big deal. All right, so all good? Okay.